The ZODB is an object-oriented database written in Python and optimized in C. The ZODB ecosystem includes all of the software, libraries, and tools which are used to work with the ZODB. And of course, any discussion of the ZODB would not be complete without a discussion of the different ideas and alternative approaches that people use. Okay, so why are we interested in the ZODB? It's so easy to use. Here we have an account object. The init method sets the balance to 0. Deposit increases the balance. With cash out, decreases the balance if there's enough money in there. So to make this object persistent, all we have to do is import persistent from the ZODB and subclass of class persistent. Notice there's no need to do a relational schema. There's no need to do an object relational mapper. As your object model changes, you don't have to keep the relational schema, the object mapper, and the object model in sync. It's just persistent Python. It's really easy. It's just a joy to develop using the ZODB. Of course, your boss doesn't care about how easy it is. What he cares about is the money. So I developed pythonlinks.info, it's the bloggery software, and my two competitors, Zeef and GLX, they both had literally millions of euros or dollars, and they ended up with worse solutions. Why? Well, they used a relational database, and they did the architecture in such a fashion that there were just 2 or 3 levels of hierarchy. If you're modeling the Python world, there's just too much stuff out there. I have parts of my tree that go 10 levels deep. If you want to, for human factors, you want to keep things to 7 items or so in each level, you just can't do that on a 2 or 3 level hierarchy. No way. How much did it cost me to do it? Well, I just did it myself. It wasn't that hard. Actually, in the time I did it, I released 3 applications, not just once. It's so much faster and easier and more pleasant to write on the ZODB. Okay, so let's take a look at this database. It's a proper ACID database. The computer scientists talk about ACID properties. You know, it just works. I do transactions, it saves them. Multiple people do transactions, they don't conflict with each other. Data doesn't get lost. It's just brilliant. Actually, it's incredibly robust. I've thrown a lot of bugs at it, and it just does the right thing. It's really impressive software. And it not only stores the data, but it stores the versions of the data. So saying you're doing a content management system like Plone, this is actually the user interface from Plone for looking at previous versions. So if you're doing previous versions, you can see the different versions, you can compare different versions, you can restore them. It's brilliant for content management systems, it's great for through the web development. If you're using something like Emacs, it just stores your current version and your previous version. If you're doing something like GitHub, when you make a bunch of changes, it'll store that version. The ZODB, it stores each of your incremental versions until you pack something. Very nice. Is it a graph database? Well, Jim Fulton says it isn't. I think it is. It depends upon how you define a graph database, I guess. The preeminent graph database is Neo4j. It's done in Java. Neo4j has 2 classes, one of which is a node and the other is a link. So somebody actually implemented that on top of the ZODB, Graphagus, those 2 classes, and here's one of their images. It's a graph. The amazing thing is it only took them 420 lines of code. There are so many interesting applications done on top of the ZODB very cost effectively. Just wonderful software. So this graph stuff is used in ZOP, it's used in Grok, it's used in Pyramid, it's not used in Plone. They just see the world as a tree. Really, the simplest way to start using the ZODB is as a tree, as a hierarchy. So here we have a view of the ZODB as a hierarchy of objects. You can think of each node on the tree as a dictionary. Really, it's a B tree. So it persists the objects on the file system, but it appears to the developer to just be a dictionary. You can compare that to the relational database on the right. How does this compare in terms of software? Well, let's write a very simple application. Let's iterate over all of the objects in a node in ZODB and print what the dunder rep is. Dunder rep, what it does is it returns a string representation of the object. So you have to actually load the objects to calculate that. If I wanted to do that on a relational database, well, I've got 10 different classes, that means 10 different tables. I would have to do a join across all those tables, across all those different tables. Frankly, I don't even have to do it. Here it's just literally 2 lines of code. So fast, so efficient, brilliant for this type of application, much better than using a relational database. So given a tree, it's really easy to build a directory. I built pythonlinks.info, one of the world's largest Python directories. There are multiple Python directories out there. Sadly, people don't care that much. The Python developers do like this quite a bit. There's significant interest. But what people really care about in general is they care about money. They care about jobs. They care about companies that they can work for. So I built another application on top of here. Here's the company's data structure. It's a directory of Python companies around the world. You can see at the top level we have basic category object, the world. Under that we have the different regions. We're going to look at Europe. That's a different class. Next class underneath that is the countries. We're going to look at Poland. Next class under that is the cities. We're going to look at Katowice. And next class under that are the companies. We're going to look at Bloggery. And under that we have several different classes: YouTube videos, products, applications, jobs, careers, and then just regular links either to blogs or maybe product reviews. So here you can see how easy it is to implement a rich hierarchical object model on top of the ZODB. Of course, end users don't want to see an object model. What they want to see is tables. So here we have a view of a node in polandtrade.info, fintech. You can see in the upper left where we are, Poland trade directory by industry, Poland software industry, fintech, and within that you can see a table. On the left hand side you see the company name. You can click over it to it. On the right hand side you can see what they specialize in, so you can find who's interesting to you. You can see links to their jobs, a column of jobs. If they have jobs, the line turns green. Links to products, there's a column for links, for other links, blogs, reviews, product reviews, what it's like to work at the company. So Bloggery and ZODB allow for very high information density. People really like this stuff. How do you access a particular object? Well, if you're on a relational database, you'll use dispatch, but in the ZODB world, you navigate the tree. And so at the root, you get slash. If you go to the right, you get slash software. If you go below that, slash software slash libraries, and then slash software slash libraries slash database libraries. Think of each of these nodes as a dictionary. It's really a B tree. The items underneath them have names, and so it's very easy to take a URL, partition into segments, and each of those segments helps you navigate to the next item on the tree. Of course, you can go even further than this down. How do you store the objects? Well, there are multiple ways to store the ZODB objects. The basic one is you can store your object model in a file storage in multiple files on the file system. Large chunks of data such as images or LibreOffice documents or LibreOffice spreadsheets, you can store them in blobs. If you need higher performance, you can do the client server. So the ZO server will store the data in files and blob stores, and the ZO client will have a cache of that. Multiple ZO clients will have a cache of that. If you need greater performance or you need to store in a relational database, you can go with RHEL storage. That can store in Oracle, MySQL, or PostgreSQL. And if you've focused on PostgreSQL, then you can use NewtDB, which has the advantages that it takes advantage of JSONB and the catalog and indexing features on Postgres. So lots of options there. Taking a closer look at ZO, here we have the clients. They all access through the internet to a load balancer, and from there it can go to multiple ZO clients, and then those will actually fetch the data from the appropriate ZO server. So the ZO server will be the persistent store of the data, but for performance, the different ZO clients need to have a cache. The cache can be in RAM, it can be on the file system. There'll be multiple objects in the cache. They can update those objects. When they commit a transaction, they'll upgrade on the server. And then the other objects that have a cache, a copy of that will get their cache invalidated. They can go fetch the updated version from the server if they need to. Scalability, ZODB scales very nicely. Jim Fulton, the ZODB author, says that at Zope Corporation, several hundred newspaper content management systems and websites were hosted using a multi-database configuration, with most data in a main database and catalog database. The database had several hundred gigabytes of ordinary database records plus multiple terabytes of blob data. If you need even more larger databases, you can use a cousin to ZODB called Neo. This is not Neo4j, this is Neo from Nexeti.com, and they have up to 80 terabytes in production, 150 terabytes running in test, and they're working to increase those numbers. For security, ZODB now does SSL connections between ZO clients and ZO servers. If you want more security, say you're on Microsoft where everything has to be hosted in the cloud, and you don't want people reading your data on the cloud, what you can use is something from called ZeroDB. You can get that from GitHub. And what that does decrypts everything on the client, including the indexes. So the servers have literally no knowledge of what the data is that they're hosting. Very interesting software. This is another example. 2 people released this. There's so many innovative products that come out of the ZODB world. It's just fast and inexpensive to bring up new products. Let's take a look at how to actually build a ZODB database, import the appropriate stuff. You can create a file storage, it's a basic one. You can do RAM storage, you can create a relational storage. So there's a command to create the database. You get a connection to it, and then your root object, you get a root object, and then you add things to the root object. So remember our account application. Here we create an account object and we add it to root.account1. But really, people have large collections. You don't just create one account, you create a collection of accounts. So what you do is you create one of these B trees container. And so root.accounts is a B tree, and then you add things to the B tree by name. So account-1 would be added to it. Actually, what people really do is they build an account management application. So root.accounts is the account management application, then they interact with it too, and that then adds the accounts. Of course, you have to commit your transactions, import transaction, transaction.commit. Notice there's no begin transaction here, there's just a transaction.commit. And the reason is that ZODB is an optimistic concurrency control database. It assumes there aren't going to be any conflicts. If there is a conflict, it throws an error and the applications deal with it. In most content management system, I'm updating an article, somebody else isn't updating the article at the same time. So it works for all my applications, it works just fine. Everybody has their own content they add. If you have a problem with conflicts, maybe you can restructure your object model to reduce the conflicts. Maybe if you have a lot of very high contention database, then ZODB is not the one for you. It's just Python. People ask me, okay, well, how do I do a select? Well, there's no relational database in sight. There's no select. So if you want to update something, you can go root.accounts, select your account number 1. Maybe that's a select statement. Invoke the deposit function, tell it how much you want to deposit, and then do the transaction commit. You want to do a query just for key account in root.accounts, print key and account.balance, and you get a list of all the accounts and their balances, account names and balances. So it's just Python. There are some tools for building indexes into these objects, catalog, zcatalog. I think Hypatia is the one, what it's called over on the pyramid side. You can look into those if you need them. So there are a number of different applications that you can choose. Pyramid is the primary one that people use for development. Plone is a gorgeous content management system. If you're doing content management, I highly recommend it. On the other hand, and Plone is then built on top of ZOP. There's Grok, which is a very reasonably thin layer on top of ZOP. And then Flask users also use the ZODB. So let's take a look at a Plone view on an object. I'll point out that Plone is a wonderful content management system, but I discourage you from doing application development on Plone. It's just a ton of software there. It's very difficult to extend it. So in the middle box, we have a view on an object. There could be different kinds of views. Here we're reporting a piece of news. On the top and bottom, we have headers and footers. They can change based on where you are on the tree. On the right-hand, left-hand side, we have areas. Maybe they show a view into a calendar, which is a branch of a tree. Maybe they show some other information. So Plone does all this very nicely, very beautifully. There's also Pyramid. Pyramid comes with a user interface called Substance D. What we're looking at here in Substance D is the container view. So you have a container which has multiple objects in it. It's a B tree. And what do you want to do to those objects? Well, maybe you want to add something, or you want to rename, copy, move, delete, duplicate them. I call this the management view, a container view. Sort of all these tools have something like this. They're all a bit different. And then ZOPACHI, the tools I had, they're a full-blown JavaScript integrated development environment. So here you see 4 views from ZOPACHI. One is the menu bar for the HTML WYSIWYG editor. One is the technical ACE HTML editor. One is the ACE CSS editor. Another is the ACE JavaScript editor. So you can bring up basic web applications through the web very quickly using ZOPACHI. All of these have multiple views on every object. So looking at Bloggery, my directory software, there are multiple views on any single object. So there's the basic index view. You can do CK editor, which is the HTML WYSIWYG editor. You can do the ACE editor, the technical editor on an object. You can manage it. That's where you look at the whole contents of the container, everything in it. You can add content. You can manage security. At least in the ZOP and Grok world, even Plone, you manage security based on the tree. Pyramid's a bit, security permissions are on the object. You can also have the edit view on different nodes in the tree. Note that this tree, different nodes can have different classes. And so the edits can all be the same Python object, view object on all of those, or they can be different view objects. And then you get into this whole configuration problem of which edit views do you use on which objects, and who has which permissions for that. So it gets very complicated. You have to do some configuration. Initially, what they did is they created ZCML. So ZCML is, well, here you have some ZCML. It's painful. We Python developers don't like brackets. It's complicated. Maybe it doesn't do inheritance. Something simpler is needed. So first Grok simplified it, and then Pyramid took the ideas and optimized the performance. So here you have a hello method. So then when you go to /hello, you see it says hello world. And you have a decorator called a view configurator, which basically says register this as a view in the ZOP component architecture. So reasonably simple to do, but it has some problems because it's not object oriented, so it doesn't do inheritance correctly. It's very performance optimized. So at runtime, you can have hundreds of people invoking hello, and actually the whole decorator stuff disappears. Decorator is a function which returns a function, and it just returns the function. The decorator is used when you first load up, when you first scan. When an application first starts, there's a scan of all the source code, and it reads in all this decorator configuration stuff and uses that to define the database used by the ZOP component architecture. Okay, so that's the pyramid approach. Here's the Grok approach. You create class index, subclass of grok.view, return hello world, you're done. I was a bit embarrassed to show this because there's no configuration. Wait a minute, how's that possible? And the answer is it's either implicit or it's hidden by inheritance. So let me show you a more explicit view. Here is from ZOPACHI from editing containers, the management view where you get to see a container and all its contents. So you have to give it a name, grok.name manage, so that's the last segment on a URL. When you do invoke something /manage, it'll manage it. It'll invoke this view. Grok.context, well, this one works on any object that supports the iContainer interface. Grok.template, this is the basic template for the HTML called manage folder. It finds that in a subclass. Grok.require, it tells it what the permission is. So this is the basic way the configuration works for grokking. And if we go back, you can see how this stuff could be inherited. And so it makes it really easy to bring up new sites. It's also really good for beginners because when I was a beginner, I just thought that this was Python code being executed. There's no complexity, no additional mental load on the beginner. And it took me about a year to realize that actually this isn't executed at runtime. There's at the scan phase, when all the code is scanned, this stuff is read in, interpreted, and entered into the ZOP component architecture database. But so very nice user interface, works. I really like it. The other thing that's great about Grok and ZOP is they have cred for free. So here you define your schema of your Python object. This is from the Mammoth tutorial for Grok. Grok is a caveman and he had a pet mammoth. And so that's the tutorial. You have this furriness, you have the weight, you have the owner, there's some title, there's some description information required, you tell it what the type of the information is, maybe what the default objects are. There are a bunch of different values you can assign to these things. Actually, I don't remember them, but once you have this kind of structure for schemas, you can pop up a user interface. And so Apache does this, and so it's possible to define your schemas through the web. And this is, again, brilliant for beginners because you just see exactly, I mean, you don't have to remember, you don't have to look up, very few errors. You just click, 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 and you get your schema defined. Very nice. And of course, Grok and Zope do CRUD, not just on individual objects, but even on trees and object. Here's from an application I built, PrivacyV. It has, it models people for a resume database. And of course, people are quite complex. So you've got their contact information, their credentials, their resume, notes about the person, questionnaire. And Z3C.form will take this kind of tree model and pop up forms. So that's really sweet. Of course, when you're dealing with people, you've got all these security requirements. And so, for example, people may want to publish their resume publicly on the web, but their contact information should only be visible to hiring managers. And so I had to add permission objects to this tree of objects so that different pieces would get displayed appropriately or not. Not that hard to do. Okay, so those are the basics. Let's now do a comparison of Pyramid, Zope, and Grok. And basically what Pyramid does is it really strips things down to have optimal performance. And what Zope does is it's more focused on very high-level abstractions. There's a performance penalty for those, of course. Maybe Zope has too many high-level abstractions, and so Grok came along and simplifies all of it. So let's take a look at security. In the basic tutorials on Pyramid, I'm not a Pyramid expert, but you take a look and every object has ACL list, access control list, of who's allowed to see what. If you go to Zope or Grok, the objects don't have permissions associated with them. What happens, directly associated with them, what happens is you have permissions on views. So say you want to view or access or edit, you get a permission on the view. And then different roles can have multiple permissions, different principals can have multiple roles, and different branches of the tree can then acquire these permissions and roles. Different branches of the tree can set who's allowed to do which permissions, which roles are allowed to do which permissions. So here we have, so it's a much higher level abstraction, and of course Pyramid does the greater performance solution. So they both do views on objects using the Zope component architecture, but Zope and Grok also do Zope component architecture on arbitrary objects, and so they call it adapters. It was very hard to describe that. I think it's really much better to think of them as abstractors. So when you have this container view, what used to be called the Zope management interface, you've got cut, copy, paste, delete, name, remove. And then there are various adapters for that, iObject mover, iObject renamer, iObject copier, iObject deleter in zope.copyPasteMove. And those provide a high-level interface. So let's take a look at the actual source code. On the right, you have source code, which I copied a while ago from Pyramid. Substance D, from the Substance D interface to Pyramid. And so the objects have this method called, the objects have an instance variable called deletable, which can boolean if it's true or false, or it can be a function, or it can actually be even to none. And then based on that, the object can be deleted or not. In the Grok Zope world, you have conceptually you have the iObject deleter, so you use the abstractor concept to get the iObject deleter for a particular object, and so that you can have different object deleters for different objects. So I have different kinds of objects. I have Apache objects, I have BlogRay group objects, I have BlogRay private objects, and for copy, paste, move, delete, they're all treated a bit differently. And so the BlogRay abstractors makes it a lot easier to manage all of that code. Okay, on to the next concept, Plone versus BlogRay. I'm less concerned about comparing the particular applications, and more concerned about the difference in ideas. So Plone is a content management system. We all know what that is. Bloggery is a content aggregation system. Generally, people don't talk about that. In 2000, when Plone was released, great. You put up a website, people contribute lots of content. Now you put up a website, people are more reluctant to do so. But also you get wonderful content all over the internet. So what I do is instead of, Bloggery is a content management system so people can add content through the web, but primarily what I do is I import high quality content from lots of places. So you get very crystallized content that's published and open sourced, often on a Creative Commons license. That can be as XML, Markdown, RSS, Atom, YAML or through a web interface. That can all be imported into Bloggery. And what happens is it get merged. So here on the right you have a basic ZODB tree that's for the group Bloggery. That could also be for Plone. And on the left you have the content that's also stored on Bloggery, but it also comes from some other source and gets updated. So what I do is I keep a copy of the previous version, and when I import a new version, it's a lot easier to see the differences and then upgrade the group Bloggery based on that. So this is the essence of a content aggregation system. What are some of the other differences on Plone versus Bloggery? Again, at the conceptual level, the important thing that Bloggery does is it has canonical URLs. So for every node, you want to give it a single URL. And if you have a large tree and you're reorganizing the tree from time to time, the URL is going to change, so that's not good. So what I do is at the root, there's a Python dictionary, and that Python dictionary links to all of the individual objects. This is very much a graph type of application. And so just if you give it the name at the root level, it takes you directly to that object. So that's really sweet. Last set of conceptual differences between Substance D and Zopachi. Remember, these come from very different communities. Substance D is, and if you go to defense of Pyramid, it's very clearly that they're in the space of doing large corporate applications with multiple installations. Zopachi is very clearly for the startup community. You're bringing up one application, one website. And so we do things differently. And then, of course, Substance D is a very strange beast because you're storing the content types on the ZODB, and so the whole issue, the sort of Git types of source code control for distributing and doing versions aren't there currently on the ZODB. And so it's kind of a big dissonance, cognitive dissonance within the Pyramid community. And if you go to the Substance D webpage and you read their article, their quote about where the name Substance D from the book and where it comes from, it's very clear there's huge dissonance there. And I totally understand it. I actually did the same thing that they did, which was doing content types to the web, and now I realize that's just dumb. You want to do your basic content types, you want them to be Python classes, because then you can upgrade and expand to different versions. But it's fine to do the instance variables through the web. That works really well, and it's also very easy to then migrate them down onto the file system later if you want to. The other thing that Substance D and Zopachi does differently is Substance D, large organizations, they want their whole website to look the same, so they discouraged using through the web HTML editors. Zopachi, I'm much more concerned about bringing up a website quickly, not only CK editor for WYSIWYG, but ACE editor, all the CSS, JavaScript editors as well. It works brilliantly for a single website, single developer. And then the other big difference is through the web classes. So Zopachi is very focused on through the web development. There used to be something like this in Zope 2, it's disappeared. Let's take a look at this. So here we have a tree of objects, and you have, imagine that they all have a Python class. And in the upper right, you've got the Python class information, maybe a tree of items. But the problem with Python classes is all you can literally add to a Python class is Python code. Whereas once you're doing this through the web stuff, you can upload an image or you can upload some HTML or a file. And what you'd like to do is have a web class where that image that you upload appears to be part of all of the objects that have that web class. And so I've done that within Zopachi. Works brilliantly. I think that's a huge part of my productivity gains is because I had the correct abstractions. Okay, back to ZODB. There are multiple object databases you can use, multiple databases you can use. I guess they're called NoSQL databases. Mongo, Redis, Neo4j. I'm not an expert on all of them. The question is I can give you some few words of advice on how to select a database. So the first one is it ACID compliant? It turns out a lot of these document databases, you try to do a transaction across multiple objects, it's not ACID compliant. Are they a graph database? Well, that's easy to check. Many of them aren't graph databases. Do they support persistent Python? They're probably better at that. But if you take something like Neo4j, which is implemented in Java, it's statically bound language. If you try to add an instance variable to a single Neo4j object, I don't think it's going to allow that. Maybe any Neo4j experts here. And finally, do they support history? If you're doing content management systems or through the web development, it's really sweet to keep history around. So Neo4j, graph database, very interesting. The people who implemented Graphigus were really did a performance comparison to Neo4j. These numbers are from 2015, June, so they asked me to just be very careful to point that out. Since then, Neo4j has gotten $35 million in investment. I have no idea how all these companies do such huge investments, but it's certainly impressive of how inexpensively groups like Graphigus, ZODB managed to bring up applications on top of ZODB. If you want to contact me, I invite you to go pythonlinks.info, click on contact, or better yet, follow me on Twitter. So if you go to @pythonlinks on Twitter, I invite you to follow me. It's a great way to stay in touch. And I just have one last word of advice for everybody from our dear friend Grok. Here's a picture of Grok the caveman. Quit using a Stone Age database. Download the ZODB today. Thank you very much.